Okay, sorry about that, guys. We had a little technical problem. Hopefully we're good to go now. So let me just take a step back for just a moment and make sure we're all on the same page. So we're solving this inequality, which is negative x squared plus x plus 12 less than 0. And we are going to first find where it equals 0. So you set negative x squared plus x plus 12 equal to 0. And you solve using quadratic equation methods of solution. So in this case, I divided through by -1 to make my leading coefficient positive, and I'm going to solve using factoring. You could also use a quadratic formula, but when factoring is straightforward, that's the quickest way to go. So we just found that this the solution to that equation is x equals 4 or x equals -3, which means the left side of the inequality is actually equal to 0 at those values. So I'm going to put on my number line over here, which we call a sign chart, in numerical order, the -3 and the -4. These are x values, so I'm going to put x on the bottom here. And these represent where the expression negative x squared plus x minus 12 is actually equal to 0. Okay, now what I'm really interested in is solving this inequality, which is asking me to find where it's less than 0. You should translate less than 0 into what it means to us on a sign chart, which is where it's negative, because our sign chart's going to show us positives and negatives and zeros. So our solution will be any intervals where we have negative values. We haven't figured out those intervals yet. So how do we do that? Well, one way to do it is to plug in values between the zeros. So for example, to the left of -3, you could use a number like -5. Between -3 and +4, an easy number to check would be 0. And after the number 4, an easy value to check would be like 6. So you can plug those into the expression to see if you get positives or negatives. So in our expression, plugging in -5 for x, we would have the opposite of -5 squared plus -5 minus 12. And we just want to know, is that going to turn out to be positive or negative? Well, that's going to be -25 minus 5 minus 12, which is definitely going to be a negative number. So since our expression can only change from positive to negative at one of these zeros, we know that every value to the left of -3 is going to give us a negative, just like -5 did. On the other hand, if we plug in 0 to the expression, we're going to have the opposite of 0 squared plus 0 minus 12, and that is going to give us a negative as well. Oh, that was supposed to be a plus 12. Oops. Sorry, guys. Copied that down wrong. Okay, so anyways, we still would have gotten a negative when we plugged in -5, because -30 plus 12 is still negative. 0 plus 0 plus 12, though, is going to be positive. So we know everywhere in between -3 and +4, we're going to get a positive no matter what number we plug in. And then to the right of 4, if I plug in 6, we've actually already done this once, right? -6 squared plus 6 plus 12. We're going to get -36 plus 6 plus 12, which is going to be negative. So we know that we're going to have all negatives for any numbers past 4. So to answer the question that was being asked, to solve the inequality, to figure out where we have negatives, is just a matter of reading the sign chart. Where do we have negatives? We have negatives to the left of -3 and to the right of 4. So our solution set, which we'll generally write in interval notation, is going to be everything to the left of -3. So -infinity to -3, not including 0 because our inequality did not have an equal sign in it. So just a parenthesis there, union with 4 to infinity. Okay, now this method, the sign chart method, is to avoid having to graph, but I do want to point out that if you imagine the graph of this as a function, f of x equals negative x squared plus x plus 12, it has a negative leading coefficient, which means it opens downward. And these would be its x-intercepts. So imagine placing that the graph of that parabola on top of our sign chart. It would be an open downward parabola. And you would see that to the left of -3, it's below the y-axis, and also to the right of 4. So it's consistent with what we saw where we had y values below the axis, we have a negative, so it's less than 0. And if we have y values above the x-axis, we have a positive greater than 0. Okay, let's do one more. Solving a quadratic equation using, solving a quadratic inequality using a sign chart. This time we're going to solve, and we have (5x squared plus 7x is less than 3 parenthesis y plus 4. Okay, so this one looks a little different than the last one because it's not in a nice standard form. Uh-oh, my video health is not looking good. Hold on, let me see what we got here. Here we go, let's back up. Okay. All right, so here's the new quadratic inequality that we're going to solve here. Now, how do I know it's a quadratic inequality? Because of the exponent. There are some videos in my math lab about that you can watch, but I want to focus now on quadratic inequalities specifically. All right, so what we would do is we need to get it in standard form, just like when you're solving a quadratic equation. We don't like to solve it in this format. So I'm going to distribute the 3 on the right. So we have 5x squared plus 7x is less than 3y plus 12. And now I'm going to subtract the terms that are on the right over to the left. So I'm going to subtract 3y 0. I'm going to pause because the video output's low again. Let me see. Just checking on the video output, guys. Hold on. Okay, looks like we're back to normal now. All right, so the next thing that we're going to do is, just like we did before, our goal is to set up a sign chart, and the sign chart is just a number line, and this number line has to have all the places where the expression on the left equals 0, and then where it's positive and where it's negative. So this is our sign chart. It's going to have all the places where our x value is 0. And then we're going to figure out in between those zeros where we have positives and where we have negatives. In this case, and it's not always the case, but in this case, we're solving to find where the value is less than 0, which means negative. So we need to find the places on our sign chart where we're going to have negatives. All right, so where does it equal 0? 5x squared plus 4x minus 12. We want to know where that equals 0. We can use the quadratic formula, or we can use factoring to try to figure that out. All right, if you want to know if factoring is going to work using our AC method, recall that this is A and this is C, and you would have to find the product AC, which would be 5 times negative 12 is negative 60. You would have to find factors of negative 60 that sum up to B, the middle term, which is 4, the middle coefficient. They would have to sum up to 4, okay? So well, let's go ahead and do it. Otherwise, you can use the quadratic formula if you don't like this approach, but either one will work. All right, so in order to find that, I would be looking for pairs of factors of 60, like -1 and 60, and they would have to add up to a positive, so it would be the smaller number that would be negative. Could be that's going to add up to 59, so that doesn't work. -2 goes in 30 times, that adds up to 28, so that doesn't work. -3 goes in 20 times, which adds up to 17. -4 goes in 15 times, which adds up to 11. We're getting closer. -5 goes in, let's see, that'd be 12 times. And that adds up to 7. And -6 goes in 10 times, which adds up to 4. So remember, what we use this for is to split the middle term. So we're going to rewrite this as 5x squared minus 6x plus 10x. This minus 6x plus 10x is replacing the 4x there. And this allows us to use grouping. This is my preferred way of factoring trinomials that have large coefficients of x squared. So then we're going to factor out an x from the first pair, leaving 5x minus 6 behind. The second pair has a 2 in common, leaving 5x minus 6 behind. And then we're going to factor the 5x minus 6 out, leaving x plus 2 behind. All right, so now we have a factored. So we can find where those two factors equal 0. 5x minus 6 equals 0. Places where the expression is equal to 0. All right, if we want to know where it's positive and negative, there are two ways you can think about it. I'm going to pause because the video is doing weird things again. Hold on. Okay, sorry about that. We're back. All right, so we found that the expression 5x squared plus 4x minus 12 is equal to 0 at -2 and 6/5. There are two ways you can go about figuring out where it's positive and where it's negative. One way is to actually plug in test values on each of the intervals. So for example, on the interval that's less than -2, you could test the value -3 by plugging it into the expression. On the interval between -2 and positive 6/5, you could test the value 0. And on the interval past 6/5, you could test 2 or 3 or 4, anything bigger than 1 1/5. All right, but another way of doing it is, since we know this is going to look like a parabola, and it's a parabola that opens upward, if you can imagine it kind of superimposed on top of this sign chart. I'm going to put it in yellow. Pretend that we were graphing it. It's going to go, since the leading coefficient is positive, it's going to go upward, open upward. So it would be positive on the left and positive on the right, and it would be negative in the middle, right? The y values would be above the x-axis on the left and right and below in the middle. Let's just confirm that by plugging in to the expression. All right, so if I plug negative 3, for example, into 5x squared plus 4x minus 12. Pausing, hold on. Okay, sorry. So if we were to plug negative 3 into 5x squared plus 4x minus 12, let's just confirm that we would get positive. 45 minus 24, what, 21? But anyway, it's definitely greater than 0. It's positive. And you could plug in 0 and 2, each of those, to that expression and confirm that you'd get negative and positive as well. So now let's go back and answer the question. The whole point of this is to get this sign chart set up so we can literally read the solution to the inequality right off the sign chart. So looking at the sign chart, we have negatives where, remember less than 0 means negative, so we have negatives right in the middle between negative 2 and 6/5. So the solution to the inequality is going to be the interval from negative 2 to 6/5. Now, are we including those endpoints? No, because this is strictly less than. There's not an 2 there. So that means we use parentheses. And so our solution is the interval from negative 2 to 6/5, not including the endpoints. All right, so that's how you solve a quadratic inequality using a sign chart. First, you get it in basically standard form with 0 on one side. And then you set it equal to 0 to find out where the boundary points are going to be. Plot the boundary points on your sign chart, and then test points in between those to find out if it's positive or negative, or use your knowledge of parabolas to think if it opens upward or opens downward. All right, now we're going to move on now to exponential functions. Oh, and we have streaming issues again. All right, so next we're talking about exponential functions, and I'm sorry that we keep going in and out here. Exponential functions, all I want you to do with these for test 3 is just be able to draw them and plug into them. So, for example, let's see, let's get our graph paper out here. Okay, so first I have to explain the difference between the functions we've seen that have exponents in them and what's considered actually an exponential function. These are two different things. So we've seen the function f of x equals x squared a lot, right? And that definitely has an exponent in it. So you might think it's an exponential function, but remember it's not. We considered this the square function, which is a type of quadratic function. We've also referred to anything of this form where the base is a variable and we have an exponent. We've referred to them as polynomial functions. So what the heck is an exponential function? We have an exponent there, but we're not calling that an exponential function. The difference is that in these, we have the x in the base of the exponential expression. On the other hand, let's look at the function g of x equals 2 to the x. In this case, we have the x in the exponent, and that's what makes it an exponential function. Okay, now you may have heard of exponential growth, and in exponential functions, you'll see why we often use that expression to mean things that are growing very quickly. Just to give you an example, if we were to use just plotting points to graph g of x equals 2 to the x, let's see what would happen. So for example, let's use a little bit bigger scale so we can see what's going on here a little bit better. A little bit bigger scale on the x, and a little smaller scale on the y. Okay, so what if I plugged in the number -2 to g? What would g of -2 be? G of -2 would mean 2 to the -2. Remember, a negative exponent means 1 over the positive version, so 1 over 2 squared, or 1/4. So we would get a tiny little fraction if we plugged in -2. So how about g of -1? Well, that's going to be 2 to the -1, which is 1/2. So we'd get a fraction there as well, a little bit bigger, but still pretty small. And what if we plugged in g of 0? What's anything to the 0 power going to equal? It's going to equal 1, right? So that means it goes through the point 0, 1. And what if we plugged in g of 1? Well, g of 1 is going to be 2 to the first, or 2. So we're going to go through the point 1, 2. And what if we plugged in 2? Then we would get 2 squared, which is 4, which would be here. And what if we plugged in 3? Then we're going to get 2 cubed, which is 8. Notice that the y values are doubling every time I increase the x by 1, which causes what we call exponential growth. So what happens is, at first it's growing fairly slowly, then it just kind of explodes. Sorry, got issues again. Okay, so this graph of g of x equals 2 to the x is what all the exponential functions that have bases greater than 1 look like. So if you had, for example, y equals 3 to the x, it's going to look very much the same as this graph. Of course, the points value, the y values would be slightly different. It would go through 1, 3, it would go through 2, 9, and it would go through 3, 27, but it would still have this same basic shape to it. So in general, what you want to add to your, memorized library of functions for this section is that if you have anything of the form y equals b to the x power, where b is any number greater than 1, like 2 or 3 or even 5.5, it doesn't matter, anything bigger than 1, then your graph is going to go through the point 0, 1. It's going to go through the point 1, and then whatever b is, those will be your 2 key points. It's going to be an increasing function, increasing from left to right. So as we read it from left to right, it's like we're going uphill, yeah? And it's always going to have an asymptote at y equals 0. So if I ask you to graph anything of that form, you can very quickly come up with the graph. So let's look at an example. What if I asked you to graph f of x equals 5 to the x power, right? So you would need to recognize that because the x is in the exponent, this is an exponential function. And that your two key points are going to be 0, 1, and 1, 5, whatever the base is. And then you're going to graph the asymptote, and we would go through 0, 1, we would go through 2, 3, 4, 5, 1, 5. We would put in our asymptote. I'm going to make it a different color maybe here. Y equals 0. And then we would draw our graph, gradually increasing and then gradually increasing to the left of the y-axis, and then we're going to quickly increase on the right, very steep. Pausing because we're having streaming issues again. Hold on. Okay. All right, so that's how you graph just 5 to the x. All right, but of course, you know that we can take any function and we can do transformations on it. So I want you to be able to do transformations on these functions as well. So for example, if I asked you to graph f of x equals 5 to the x minus 1 plus 2, how would that change the... You're going to shift to the right 1 unit. You're actually going to add 1 to each of the x's. The opposite of what you would think. And we're having issues again. I'm sorry, guys. It's getting more frequent. Okay, and then this plus 2 is on the outer part of the function, so it's going to affect the y coordinates. We're actually going to be adding 2 to each of the y's, which is going to have a vertical shift. All right, I'm going to refresh this stream real quick so we can see what happens. Hold on. Okay, so we're back. So we're going to take that graph that we just saw up here of f of x equals 5 to the x, and we're going to shift those key points 0, 1, and 1, 5, and the asymptote y equals 0. We're going to add 1 to each of the x's and add 2 to each of the y's. And let's see what we get. So instead of going through 0, 1, we're going to go through adding 1 to the x would be... So our function would look like... Oops, wrong graph. Shifted up and up and to the right. Up 2 units and to the right 1 unit. Okay? So that's the basic idea with exponential functions. Now there is one other thing to take into consideration. I'm going to refresh the stream before we do that because it's getting bad again. Okay, so the other thing is, what happens if you have a number less than 1 in the base of your exponential function? We'll never have a negative. By definition, that would not be an exponential function, so that's not going to happen. But what if, for example, I asked you to graph f of x, or let's give it a different name since I have an f there already. What if I asked you to graph h of x equals 1/5 to the x power? Okay, so you might recognize that 5 to the x and 1/5 to the x are reciprocals of each other. So really, this could be thought of as a transformation of 5 to the x. You could think of it as 5 to the negative x power. And what happens when we negate each of the x values? We reflect over the y-axis. So h of x equals 1/5 to the x looks exactly like 5 to the x, but flipped over the y-axis. So it's going to still go through 0, 1, but it's going to go through -1 as a reflection of its reciprocal. Either way, you're going to end up with the right graph. Okay? All right, so that's all I'm going to say for today. There's more in this section, but remember this is a blended class, and so you're going to have to look on your videos on my math lab. Go ahead though and contact me if you have any questions. I hope you have a good weekend. Remember the test 3 is due this upcoming Thursday. So let me just make a note of that. Test 3 due Thursday. Okay, and it will include quadratic inequalities and exponential functions. Thanks for watching today. Sorry for the interruptions. Hopefully I can... Every time I do this, it improves a little bit, so I appreciate your patience. Eventually, future students won't have to deal with all of the cutouts, I think. All right, have a good weekend and email me or Skype me if you have questions. Bye-bye.